So, hello guys, and welcome to this new video. I don't know what to say, to be honest. Like, yesterday I made this video, I showed you this configuration, and all of you believed me. Come on guys, it was April 1st, what did you think? That I made this 9-tuple spawner? Like, okay, sure, some people can make a mistake, but yeah, I just find it a bit saddening that all of you guys just, like, thought I was being serious. I mean, Jesus Christ, you think I made a 9-tuple spawner? Come on. I made a 16-tuple spawner. Anyway, let's continue. So, today I want to make a bit more of a serious video. All of the spawners which don't have stone on top of them are spawners. So, I do not entirely know how I want to make this video, so I'm gonna first do a bit of a demonstration of the results I got, and the second part of the video I'm going to go more into how I got those results. Now, first of all, let's go into game mode 1. So then we're gonna go over here, and as you can tell, we have all of these spawners, except for the ones which stone on top of them, or the ones which are just kind of far away, are, yeah, they're all, what I'm trying to say, they're all in range and they're all skeleton spawners. If you want to check that, well, you'll have to check the world, I'm afraid. Or you can just pause the video right here or something, and we got a good angle. Now you can see all of them, I think. So, how did I get this? Well, as I said, I'm going to cover that later on. First of all, you're probably wondering, why do you have all those other spawners? Well, again, that's going to be covered in the method. But yes, I did generate, I think, 36 spawners in order to get the 16 which I needed. And it's also worth noting that this was at a predefined location, so I did not mess with the location in order to get good chances. I not also mess with the seed to get good chances. This is something I can't really prove, but you'll have to take my word for it. I basically created a world with seed 0, and for some reason it looks like seed 0 isn't accepted as a normal seed, because it created this seed, and every time I've tried to create a world with seed 0, it gives me new seed. So I don't know why it doesn't consider it like a real seed or something, but yeah, so since I thought for a while that I was working with seed 0, this is what I'll be working with. So yeah. Anyway, you can not download this world in the description, but I will give you another world to download. I think I'm done with this world, so let's move onto this world, Dungeon Test 3. So in here, this is the old configuration, the way it looked like before I generated anything. So yeah, just a bunch of, well, just a bunch of dungeons. You have with a certain floor count. Interestingly, this one has all the complete floor count, okay. And yeah, so on and so forth. Not too much to say about this. Anyway, I just wanted to show you. This is the world you can download in the description. Now, if you want this to work, well, first of all, you should probably put it on peaceful, unless you're gonna have a lot of this stuff spawning. Now, this stuff you can't see, but I'm basically doing stuff in MCL in the background. At least if my world is cooperating. Okay, there we go. Now I'm inside the world in MCL. All I'm doing is I am going to select a 3x3 chunk region, ranging from -2 to -2 to 0, 0 in the chunk coordinates, and I'm going to repopulate those chunks. And now I close MCL. Now when we go back into the game, it will normally just populate all those things, and as you can tell, yep, it generates spawners in all these positions. So, also something I have to mention, these spawners are only actually generating in 5 out of the 9 chunks. The corner chunks, I have some problems with those, I'll get into those later, but I just ended up not using them. But again, I'm going to go from that more in the methods behind this. Yeah, I guess that's all I can show. Like, you can do this yourself. You need MTLs, or you need some way to repopulate your chunks, unfortunately, but apart from that, you can test it for yourself and see that indeed it works. So I don't think there's that much more to show as far as the demonstration is concerned. So yeah, this uses multi-layer, well, again, methods. I'll get into that later on. Yeah, this video is a bit hard to structure for me, but I just wanted to rub it into SLF's face because he said that there was a theoretical limit of 25, which I admit I haven't reached yet. But the thing is, I think that was him saying there was a theoretical limit of on any location in any world. And you know, there's a lot of locations, a lot of worlds you can create in Minecraft, or at least you have like 2 to the 48 seeds, and then within one world you have 300 million blocks divided by 16 for each chunk. So if you want to try it centered around one chunk every time, you're going to have to take this number, like subtract 2 from it from the edges or something, but that's not going to be very relevant, and square that, and that's the amount of possible positions per world. So if I can get 16 at an arbitrary position, I wouldn't be surprised if you can get more than 25 at any position in any world. Okay, so with that out of the way, I think it's time to discuss the method a bit more. I'll probably stay in this world while I do that. First of all, this is using multi-layer spawn generation, of course. Someone to mention, I need to link, I will link to Omegang's video in the description. He made an octopus skeleton spawner a couple of weeks ago. He made a video, and I'll link to that. And that was in a large part of the motivation for me, because I was starting to get afraid that someone was gonna actually write a program to do multi-layer spawn generation, and that was the whole thing I wanted to do. I mean, it's not a terribly original idea, but it does quite a bit of work no one had taken the time to do up till this point. But yeah, it looks like I'm the first with this, so that's nice. Or at least multi-layer dungeon generation, manipulation. Natural generation sometimes happens across multiple dungeons. Anyway, what do I mean with multi-layer? Well, as you may or may not know, each chunk tries to spawn 8 dungeons. And with Omegang's script, I discussed a bit with him, and what I got from it is that he basically used the 8 default locations, which he tries if all of them fail, to spawn an actual dungeon. And he tried using those default locations. He tried to find a cluster with at least like a range in which there would be at least 8 spawners from 8 different chunks. Because the problem is, once you generate one spawner, that's going to affect the random number generation. So when you generate one dungeon, that's going to affect the random number generation from that point onward. As a result, you are not going to have your next positions are going to be completely different. And that's what I basically worked with. I still kept on predicting the next dungeons accurately, and so that's would be multi-layer dungeon generation. Now, where's the manipulation come in? Well, this is kind of basic dungeon tech, but since basically no one does it, I should probably explain this, considering almost no one knows about this. When a dungeon generates, at some point it's gonna go through all of the blocks in the region and set some of them to air and so on and so forth. But what's really important right here is that in the floor, in particular, it's going to look below. If there's an air block under there, then it will remove that block as well. If there's no air block under there, it will keep this block, and it will also check if it should become a mossy cobblestone block. In 3 out of 4 cases, it will become mossy cobblestone block. In fact, you can count right here. 1, 2, 3, 4 cobblestone out of 15 normal stone, so that's pretty accurate. So after 15 total, sorry. But the way it does that 3 out of 4 ratio is using random number generation. So again, this gets into pseudo random number generators and stuff, and I think that's a bit too complicated to explain. But as you know, if you're playing Minecraft for at least a bit, every world generates the same way, even though there's some kind of randomness involved. Like, you can't easily predict what's going to happen. Well, that's because it uses the same seed in what we call a pseudo random number generator. So in Java, that's the Java random class. It uses for most of these things. And basically what that means is that every time you run the same code with the same seed, it's going to give the same results. Even though the results are going to be very erratic and they're going to be hard to predict, but they're going to be the same results. And so in that sense, that's why people call it pseudo-random. So if you change the seed a tiny bit, the results will basically be completely different normally. But if you use the exact same, so basically you can predict how stuff is going to happen, and that's what my program basically does. I wrote a program in C++, which emulates the Java random class. It seems to do that exactly as it should, so that's fine. That's great. In fact, that's the basis of the entire program. And using that class, I also wrote a bunch of other code, of course. In fact, I wrote that class back in September. I just let this project, I dropped this project for a long time. And yeah, basically now I got back to it, and Wait, did I already explain the floor count? I did not. Damn it. Basically, what I wanted to say is that every time he moves a floor block, it doesn't do the random check, but every time it keeps a floor block, it needs to check if it's going to be mossy or not, and for that it needs to do a random check. As a result, that random check changes the internal seed of the random object, which in turn is going to change the future results of random number generations. As a result, basically by manipulating the amount of times it's going to do that check, or 3 out of 4 mossy cobblestone, that's going to affect the way the next numbers it's going to generate, including the next spawner. So basically, by adding more or less blocks, we can kind of choose where the next spawner is going to be. I've learned that actually we don't have complete freedom there, so I'm not sure why that's going on. I guess that the number generator is not giving truly random results when it gets to if you're always using round int or something. It's a bit strange. I'm looking into it. That, in fact, is the reason why I did not use the corner chunks. First, I ran the program just because the corner chunks are really slow. I ran the program just using the inner cross. And I also use a maximum branching factor of 10, which basically means it would only, from each, well, this is getting really into computer science stuff, and I'm just explaining this for people who know a bit about this. Basically, on each level of the search tree, I would use a maximum branching factor of 10. And using that setup, I could manage to get this configuration in roughly 9 seconds of calculation time. However, if I include the corner chunks as well, so if I increase the branching factor, I got roughly the same results. In fact, I never got something better. I even went to the full extent of not having a maximal branching factor to begin with. And then that didn't give any new results. Then using the corner chunks, I also tried that. Didn't give any better results. And I even looked a bit through the stuff because it looked really strange that the corner chunks weren't giving any good results. I mean, sure, they are. It's kind of rare for a corner spawner to end up in a good position, but normally it should happen once every 252 times. 1 out of every 252 dungeons normally, which isn't too hard to reach with a branching factor of, let's say, 63 on average on each level, and you have 8 levels, so yeah. But it wasn't working, and I looked a bit into it, and it looked like very often on different levels, using different branches, it was still getting the same positions for the next spawner. So that was really strange, and I'm still looking a bit into that. But it looks like just using round int calls, you're still going to have a lot of repetition, so you're quite limited in the freedom you have in placing the next spawner. As a result, I'm working on also implementing the chest generation code, so I can include that in my manipulation algorithm. Basically, that would first of all, it would increase the branching factor by a lot. Like, in the maximal case, it could increase the branching factor by, well, it could multiply the branching factor by 6. Right now, it's 49, 63, 63, or 81, so a geometric average of 63. Not including the one. There's also one option where it doesn't generate the dungeon at all. It just goes on to the next one, but that one is just 1. So, but it could do that times 6 if it's in the very most extreme case. So that would increase the branching factor to begin with. Also, it would do next float calls, and it would also basically use a variable amount of round int calls. Round but next int. Which is useful because it makes it even more random. So I hope that's going to give us better results, but I'm still working on that. But I hope you guys are happy with this. Meanwhile, I'm not sure I'm going to explain too much more. I'm definitely not going to publish the program yet. It's not done. Also, I would have to compile it for Windows, for Linux, for Mac, and so on and so forth. So I'm not great with C++. It's the first time I've written C++. It's also, and I've never published a C++ project. So, but at some point I will probably publish the code in some way or another, or at least the program. But right now it's not user-friendly at all, so yeah. Also, something I should probably tell you guys is that the way I'm doing it right now, I cannot actually choose the position. I cannot tell my program to like try a bunch of positions across different seeds. I need to manually go into a world using a modded version of Minecraft, which basically prints a bunch of data I need into the terminal, and I need to copy that data into the initialization of my program, and it uses that data to continue. But I need to still get that data. I'm saying it too much. Manually. So as a result, I need to go through manual effort in order to create possibilities to generate spawners at certain locations. And it's definitely not user-friendly in that sense. I don't think there's too much more to say, to be honest, at this point. Again, program won't be published, but it's working all right, I would say. I'm still working on it for a bit. I fault all of you guys. Haha. Anyway, we'll see. And yeah, I don't know. This video is getting too long, so I'm just gonna cut it here. But if you have any questions, I understand. I didn't really practice this very much. I also don't really know what I want to get across in this video, but I need to make this, I need to show this, and I also needed to talk a bit about it, I think. So that's why I made this. I won't get into the algorithm behind it much. That would take even more longer. But if you have questions, just ask them in the comments. It's probably a better way for me to get to inform you guys at this point, because I'm just rambling. Anyway, thanks for watching, guys. I hope you liked this video. Even if you didn't, please leave a rating, and I hope I will see you in another video.